Namaste. How are you? I hoping so everyone is happy and safe. Today we are going to discuss some important topics which are coming expected questions from the current electricity chapter. So in this current electricity chapter, first one is the current. According to definition of current, current I is equal to dq by dt. Current I is equal to dq by dt. If I am going to speak about the current, current can flow a capacitor of a resistor of resistance is equal to R. If I am going to speak about the capacitor of capacitance is C, if it is fully charged, that means Q is maxima. Q is maxima. It means that derivative of Q is equal to I, which is equal to 0. So that reason the current passing through the capacitor is equal to 0, charge passing through the resistor is equal to 0. Now we are going to understand the means in the expected questions from the current electricity chapter is they are going to ask you the combination of resistors and capacitors. Suppose to this is a one resistor and it is connected with one another resistor. There is a one capacitor of capacitance is the C. Now it is also connected with one another resistor of resistance is R. The current passing through this one is I, this is also R, this is also R. How the question they are asking is, what is the energy stored in capacitor? What is the energy stored in capacitor? So to find out the energy stored in capacitor, we want to come to know that what is the potential difference across the capacitor. To find out the potential difference across the capacitor, we have to do what is the potential upright first. Here current is I, even here also because of both are the equal resistors. So here amount of current is also I. This is the junction. Total amount of current getting into is 2I. Out is also 2. Here also the current passing through this one is also 2I. If you consider the current passing through the capacitor is equal to 0. So the potential across this resistor is equal to, according to Ohm's law, V is equal to I into R. V is equal to I means 2I into R. This resistor and capacitor both are in the parallel, so that the potential difference across the resistor is equal to capacitor. Then energy stored in capacitor is equal to half, you know potential, you know C, related formula half CV square. Half CV square. From this half C, V means 2I into R. So from this whole square, from this one you are going to get 2 C I square R square is the energy stored in capacitor. Simplest way, supposed to be this is a one capacitor circuit. In capacitor and resistor combination of the circuit, in this one 2I amount of current is getting into the circuit according to the Kirchhoff junction rule. Amount of current getting out of this one is also I. These two resistors are in the parallel combination. Total amount of current is getting into this one is also 2I. If you consider current, then total potential difference across the resistor V is equal to I into R, 2I into R. So you know the capacitance, you know this resistor and the capacitor both are in the parallel combination. So that reason V is equal to, you know that the relation among this to get the energy stored in capacitor is equal to half C V square. Then half C V means 2I into R whole square. From this one 2I square R square into C, that is it. Okay, this is about the first problem.